Hi guys, greetings of the day. This is Vijay Tavardhan. Welcome to my YouTube channel for learning a subject called as Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per video syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 5. The session number 5 includes the topics to be covered is called as the types of pipes, hoses, and quick act couplings. Now coming to the hydraulic pipes and hoses. The hydraulic pipes and hoses are conducting lines which provide a basic means for transporting fluid between components, and the fittings or the connectors used between the conductors, and at the same time it supplies inherent and versatility to the designers. And the hydraulic system presently uses principally three types of conducting lines. They are steel pipe, steel tubing, and flexible hose. And what is called as steel pipe? Steel pipe is nothing but the iron and the steel wire and first conductors to be used in industrial hydraulic systems and still being used because of their low cost, but suffers from serious leakage problems, especially at higher and operating pressures. And seamless steel pipes are recommended with internal surface rust, scale, and dust free. Coming to steel tubing, seamless steel tubing offers significant advantages over the steel pipes for hydraulic plumbing, and tubing can be bent into any shape and is easier to work with and can be used over and over again without any sealing problem, resulting in number of points reduced. Tubing will handle high pressure and flow with less bulk and weight. However, it may cost more as to do the fittings required to make the tubing connections. Then coming to hydraulic hose. A hydraulic hose is specifically designed to convey hydraulic fluid among the hydraulic components such as valves, actuators, and tools. It is typically flexible, often reinforced, and usually constructed with several layers of reinforcement. Since hydraulic systems frequently operate at high or very high pressures, the flexibility of hose enables components to be positioned in the most efficient or convenient places because the hose can bend around corners through tight spaces or across long distances. And the modern hydraulic hose typically consists of at least three parts, namely inner tube that carries the fluid and a reinforcement layer and a protective layer. The inner tube must have some flexibility and needs to be compatible with the type of fluid it will carry. And the commonly used components include either it could be a synthetic fiber or thermoplastics and the Teflon. The reinforcement layer consists of sorry, one or more buried fibers and spiral wound wire, or it could be a textile yarn. The outer layer is often weather or a oil or a absorption resistant depending upon the type of the environment the hose is designed for. Nowadays, there are many different types of hoses and the most common of them are called as reinforced rubber and steel reinforced Teflon. Let us understand what is called as reinforced rubber. The figure shows the reinforced rubber which consists tube, reinforcement and a cover, as I have told you the three different parts. A reinforced hose weighs much less than its metal counterparts. This can make a big difference. If a hydraulic system ever needs to be moved, reinforced hydraulic hoses can be made stronger with fiberglass or steel mesh, which helps and resists bending and bulging and failure also. Coming to the reinforced Teflon, that is steel reinforced Teflon, and the figure shows the steel reinforced Teflon. Sometimes steel can be too cumbersome itself and gives Teflon a try with the steel reinforcement because it will behave similarly to steel. If rubber's high resistance to heat isn't enough, Teflon can step in and deliver more resistance to heat. In fact, you will find this type of hose next to the boiler or blast furnace in some instances. And coming to the next type of hoses, that is called as return lines. There is no specific hose for a return line, but therefore this important piece of the puzzle can be often neglected. The return lines brings the fluid back to the pump where the pressure is then released. Less expensive hoses can generally do the job, but don't be pulled into the false sense security. If these hoses are not properly maintained or replaced, they can cause the huge breakdown just like any other part of the system. Then coming to the coiled hoses, in some cases, the hydraulic hose material matters less than the ability to easily store and maintain it. And the coiled hoses, which are as shown in the figure, fitted in the need in many auto shops. Either it could be a welding or it could be a puncture shop, etc. And engineers and mechanics love the coiled hoses because it can be pulled and used, and then it can be brought back to its original position where it belongs. Then coming to corrugated and articulated type of structure of hoses. The corrugated hoses can be used in much the same way as the expansion joints in a hydraulic system. They can accommodate the pressure surges or expansion caused by changes in external temperatures. And articulated hoses offer some design flexibility as they can be around the corners or it can swivel around other components. So this is about the pipes and hoses, and use of the right hydraulic hoses for the right application is a very serious matter. Too often critical fluid systems stand dormant because the wrong hydraulic hoses are installed and the breakdown occurs. Then coming to the next part of the session, which is called as quick acting couplings. The quick acting couplings provide a fast, convenient way to frequently connect the disconnect the fluid lines. Its rapidity of operation will improve the productivity. Though simple in concept, quick acting couplings are precisely engineered for specific fluid application. Their wider spread use of many years has been yielded a diverse variety of applications and the designs to serve not only a specific but general industrial application as well. Generally, all quick acting couplings have some common elements. They are, one is called as plug and the socket, and the plug is male half and the socket is female half. When connected properly, these parts seal and lock the joint effectively to contain internal pressure and resist any tensile forces that tend to pull the joint apart. The parts are easily disconnected without tools by disengaging a locking mechanism and a separating parts. And the pressure drop in the hydraulic hoses or pipes is going to happen because the drop in the pressure due to the loss of mechanical energy to overcome viscous force within the fluid during the flow fluid is called as the pressure drops in the direction of flow. Each component within the hydraulic system will contribute towards the pressure drop, that is, either it could be used by valves or could be from the tubings, fittings, hoses, filters, etc. And these lost energy is dissipated as heat energy in the oil, and the friction losses in flow mainly depending upon the length of the pipe and the cross-sectional area of the pipe, a roughness of the pipe surface, etc. The total allowable pressure drop on the hydraulic system must be chosen with care as the power loss is the product of the system of flow rate as well as the pressure drop. And this is an efficiency loss which has to be balanced against the cost of larger pipes, or either it could be a work for hoses and fittings. Thus, the wasted energy is dissipated as heat energy in oil, which may lead to cooling problems and shortening of the life. Hence, it is necessary to correctly size the walls, drilling, and flow paths within the manifold. And because of that, we have to select either a correct size of hoses. If I'm going to have an undersized hose, it can cause the turbulent flow and excessive heat is going to be built up. If I'm going to design an oversized hose, it can cause the weight of the system to increase, which by decreasing the flow rate as well as the cost is going to be added. And the pressure losses in the oil pipe will depend upon the flow condition based on the two types of flow. Either it could be a laminar or a turbulent. And what is called as laminar flow? A laminar flow is the condition when the fluid particles travel smoothly in straight lines. The innermost fluid layer travels in the highest speed and the outermost fluid layer travels at the surface, doesn't move at all. And whereas in case of similarly has a irregular and chaotic fluid particles motion such as throughout a thorough mixing of the fluid takes place, turbulent flow is usually not desirable as the flow resistance increases and thus the hydraulic losses increases. By thus, I'm going to stop the session number 5. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for the discussion. I will answer all your questions related to the topics covered in this session. And don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Vardhan. Have a great day. Bye bye once again.